welcome back. Cold, dreary, rainy, 40 in the 40s, mid to low 40s, freezing cold. You may hear strange noise in the background, which kind of sounds like gunfire. It is the Miramar Air Base. Once a week they all go out and I guess they practice shooting or whatever, so you hear the whole bunch of ding 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 ding. So cool. The intro, I went back to my older intro because I really don't like the newer one that you just saw in the last video. And things aren't really crystal clear, so for now I'm going to just switch back to my old one until I collect some nice footage of machining and doing different things, and then try to get it nice and sharp and clear. So for now, and I was thinking about getting rid of the intro, but everybody that does regular videos, they all have this opening little splash screen, whatever you want to call it. So I guess I'm going to keep it for now. Make comments if you like about yay, nay, whatever. Next video after this one, you're probably not going to like it. It's going to bore a lot of people to death, but it's going to be my opinion about what I think about York furnaces and what I've gone through today. Oh, today is Thursday. Monday was 2 weeks without heat at my daughter's house. So, and I don't think it's going to be fixed till Monday, which will be 3 weeks. This is ridiculous. Johnny Drinkard? The next, I got a kick out of your comment that you left on the last video. So, the first little segment of this is for you, John. Now, what else have I got here? Antenna. I know you guys aren't into ham antennas or anything, but in this video, well, the first part of this video I'm reviewing in Little Machine Shop 4-jaw independent chuck, but this at some point in the video I'm showing making my ham antenna, this little 2-meter antenna, but watch the pieces of it, because doing this I discovered a whole nother world of parts suppliers, and I didn't really clearly say it in the video. The tap that I'm talking about, I explained who the manufacturer is of the tap, but I did post on the website the company that is selling all kinds of stuff on eBay. So I'm trying to reference the company itself and all the different parts they have. So go to the minimachineshop.com. You'll find on the opening page at the very bottom a link to this place. Great stuff, great prices. Okay, then what's left? Oh, finally in this video, since we did, everybody worked together, all kinds of comments on the Harbor Freight tool holder. I'm going to do a follow-up here in this video on the Harbor Freight tool holder and the outcome of what tool to use and what to do. So, hope you guys enjoy it. See you later. Well, after my last video, John was kind enough to leave a comment as to what the Harbor Freight tool post is good for. And he's absolutely right. You can put your Sharpie in here and you can leave a perfect mark. I mean, you just run it right in there. And there we go. A perfectly straight line. Actually, it's got a gap in it. Let me take it in a little bit more. There, look at that, huh? Perfect. Alright, a few things in this video. I wish I could just do a video on one subject at a time rather than a Heinz 57, but I could, but they'd all be like 3-minute videos. Any case, yeah, homemade. This is the LMS, Little Machine Shop 4-inch 4-jaw independent chuck, and I didn't like the key that came with it, so I had made my own. But this is a pretty wicked looking thing, let me tell you. It is nice quality, and I used it for the first time here to make my antenna piece, but I'll get into that. So it works out great. As you can see, all the missing metal here, I had to make my own balancing weights to keep it from vibrating to death, but it's a nice chuck. I like it. I forgot what I paid for it. I've been sitting with this guy for a long time. Looks like some rust starting in here. I have to take it apart and re-Scotch Brite it. So that's the chuck. Really nice. Look wicked being on the mini lathe too, let me tell you. Okay, next up, been working on the antenna here. This is just the base part of it. But another kind of a kick is I had to thread that to get this guy down in there. Used the new thread gauge to realize that this was a 5/8 24. Went on eBay, and that's the interesting thing. On eBay, there's a manufacturer of the parts, or whatever called Toolmex. And I stumbled into a whole crazy world because you type in Toolmex and you see all kinds of stuff coming up on there, and they're all by the same company. I forgot the name of it. I'm going to put a link to it on my website on the opening page because I want to endorse these people. It was, I think, SPI Tool Shop or something like that. $5-6. I mean, holy cow, this thing is gorgeous. Sharper than all get out. It went right through there, tapping it. And side note, I guess, I used the 4-jaw because this was a, what, 1 1/4, I think 1 1/2 inch stock. And I couldn't hold it, of course, in any of the collets that I've got. But holding it in the 4-jaw, the marks that it makes on it are less. But in a 3-jaw, if I were to do this kind of tapping, this would be spinning and it would wreck the surface. The 4-jaw, it did not move. So the extra jaw somehow is really holding it. Oh, the other reason why I used the 4-jaw is because it was a long piece of stock. And I was poking pretty far out to do this facing and chamfering here. And I know on a 3-jaw, boom, it's going to come loose and fly out when you try to do the chamfering. 4-jaw just hung onto it nicely. So, that guy, but go and find this company. I'm looking at all the taps that they've got, Toolmex taps from the website, $5-6. I mean, that's ridiculous. These are gorgeous. So if you need to fill in some missing taps or dies, they have a lot of stuff, including end mills, cobalt and stuff I was looking at an inexpensive price. And they're in Florida, and this guy, when it was on eBay, was free shipping. And so their shipping is nothing too. Great company, jeez. So this guy's coming along, did the threading, cutting all the pieces up. I had to make a little brass thing here. This is threaded 440, so it goes right in there nicely. And I've got the 4 holes. I know I said 3, but I need 4 radials. Those are all made and threaded that just screw in there. So it's coming along, and I'll be able to start trimming antennas soon and looking at how good a match I'm getting on it. But just wanted to fill you guys in with that. That's not really what this video is all about. What I want to do, and I hope this is, can I work this upside down? I think I can, yeah. So I don't have to invert the video. This guy, we were talking about this in the last video, and here's a nice pencil to point with. A lot of feedback, it was great. Everybody got into this, thank you. But there was all kinds of different statements on sizes, and just for grins, I showed this technique in the last video. Put the magnetic holder on top of the headstock. I held a dial indicator. I threw one of the antenna rods in a collet just for fun. So I was figuring, this is going to be crude, but this will get me somewheres. So I did, I measured to the top of it, wrote down the number I got. I know the thickness of this. The compound with nothing on it was directly below it. So I could easily just pull this rod out, drop it down, and measure the height of this. So you've got the top of this, I was measuring 0.765 minus half the thickness of this, half the diameter of this, gives me 0.718 minus the height that I measured here, says the center of this guy is 0.660. So now I know the distance from here to the center, 0.660. So what I did was, what did I do? I measured the thickness of this guy, and by doing the I know 0.660 is the center, subtract off that, the tool that goes in this thing has to be 0.338 thick, square, whatever you want to call it. So I know what I'm looking for. Now, knowing that, the 1/4 inch tool, 0.250, that's going to be 88 thousandths too low. So yeah, we knew that. And just for grins, I knew the 3/8 was too high. So you take that minus the height or whatever, and yeah, it's 37 thousandths too high, which was pretty much what I could visually see. Now a bunch of people said 5/16, which converted is 312, so this is going to wind up being 25 thousandths too low, which was interesting, and a lot of people said 5/16 and they're using it. So I'm not sure how critical it is to be on center when you're just doing turning or facing. Well, actually facing, you're going to wind up with a bump if you try to do that. Another person said 10 millimeter. That's going to be way off, 56 thousandths too high. And the last one that I thought was right said 9 millimeters, which is going to be, that was the closest. It's going to be 16 thousandths too high. But just for fun, also, just to check this technique out, I went on the granite surface here with my little block, same dial indicator, and I took the number of a good. I put my other tool post in there with a tool in it, so I knew that 0.555 was an actual center on it. Then I measured this guy, this tool right here, which I knew was too high, and came up with this number. So the difference between the two was 37 thousandths, which blew me away because it came out to be 37 thousandths using this technique. So two techniques here, trying to figure out where actual center is matching up on the 3/8 bit. So I guess bottom line is the 9 millimeter would be the closest. It's high. As far as low, the 5/16 would be the closest, and you shim it up. But like I said, I'm not sure how critical it is. I've never messed around with turning high or low or whatever like that to see how critical it is. But if you're going to do parting, it is absolutely critical, because if you're slightly high when you're going to part, you're not going to cut. If you're slightly low, then what's going to happen is it's going to start grabbing, and you're going to get this number where your whole compound is going to start jerking and coming back up, and that's where you get the chatter from. And it's going to start leaving like gouges, bumps and gouges, and so when this thing goes into a dent or whatever, now it's going to take off a bigger chunk, and it's going to really bounce worse. And what happens is that I know, I've experienced, is if you start looking at the forces at play, if say you got the pressure per square inch is force over the area. So if you have, I'm talking about the gibs. I've got a nice steel gib, but I've got gib screws that are softer kind of metal. And originally, I think they were square and making dents in it, and I had said I took it to a grinder and made balls out of the gib screws, the tips of it, so that they move on the gib itself real easily. But if you look at pressure on what's going on here, if how do I say it? If you have like 10 pounds over 1 inch, of course it's going to be 10 pounds per square inch. But when you start looking at the contact area here on an actual give, it's very small. And I was just saying, okay, let's say it's 30 thousandths. So if you have 30 thousandths and you have 10 pounds worth of force here, which I know is a lot more when you're parting, you're going to have 333 pounds of force right here. And it's going to start denting this guy, flattening it out, and that's when you get more play, and then you wind up with more chatter and everything just spirals in. So my point is, you got to be on center with a parting tool, and I can just bore right into parts, no problem. If I start getting chatter, I know my give is loose, I got to readjust this, or my tool somehow shifted and it's below center. So I just wanted to share all that. The actual part that goes in this tool post is 0.338 square. Alright.